What we see here is a very similar program for an 8-bit and a 32-bit ARM microcontroller, and what we're trying to do is determine how many bits are there for each various data type, and is there a common size. So if we look here, char gil equals 0, char gil equals 0, and what we're doing here is we're actually taking these and inverting them so we can see exactly how many digits do we have for each one of these data types. So if we take a look here at gil, gil here, as it says, is an unsigned char, and we have 8 bits here for char, we have 8 bits here, and that's pretty standard whether you're using an 8, 16, 32, or 64-bit microcontroller. Char is always going to be 8 bits. Now if we go down the list here, the next one is short, and short here, 16 bits, short here, again 16 bits. But one of the things you're going to notice is as soon as we get to integer, that's when things change. Here integer is 16 bits, here integer is 32 bits. Typically what you're going to find is integers are at least 16 bits for small microcontrollers. So if you've got an 8-bit data bus or a 16-bit data bus, integers are typically going to be 16 bits. If you have a 32-bit microcontroller, integers are typically going to be 32 bits. Now if we go from integer to long, you'll see that our long here for an 8-bit machine is 32 bits. But over here, our long is still just 32 bits. Notice here our long is 32 bits, whereas our long over here is 64 bits.